How are you doing, student? I am Mr. Kumulacho. I am grade 7 mathematics teacher. Student, I hope you stay at home. Today we are going to summarize chapter 5, geometric figure and measurement. In this chapter summary session, you should be able to identify, construct and describe quadrilaterals such as trapezium, rectangle, rhombus, square, and also. Next, define a polygon, differentiate the types of polygon, calculate the number of diagonal drawn from one vertex and all possible diagonal on the given polygon. Good. Students, what does it mean quadrilaterals? Quadrilaterals is a four-sided geometric figure which bounded or enclosed by the line segment. Let's see this, a quadrilateral having four sides, and the property, the some point on the quadrilateral, the line segment of the quadrilateral is, as you see the above figure, quadrilateral DEFG, DE, EF, FG and GD are the side of a quadrilateral. The point at which the sides are connected are the vertices of the quadrilateral. For the given quadrilateral, the vertex of the given quadrilateral is a vertex of G, vertex F and vertex E, and also vertex D is the vertex of the given quadrilateral and also an endpoint of the given quadrilateral. Another main point on the quadrilateral, adjacent side of the quadrilateral, what named the adjacent side of a quadrilateral have the common endpoint, the common endpoint of the quadrilateral. So let you take two line segment DE and line segment EF are an adjacent sides having the common endpoint at C. So DE and EF said to be adjacent side of a quadrilateral. Then opposite sides of the quadrilateral are a side have no common endpoint. No common endpoint. For example, GF, line segment GF, and also DG, DE are opposite. This line GF and DE opposite side. DG, this one, and also EF are opposite side of the quadrilateral because has no the common endpoint on the given quadrilateral. Then on the given quadrilateral, another main point is a diagonal of a quadrilateral. A diagonal of a quadrilateral is the line segment which connects the two opposite vertices, or the line segment which joined a non-consecutive vertex of the given figure. For the above quadrilateral, the diagonal of the given figures is GE and also DF is the diagonal of the given quadrilateral. Then the interior angle of a quadrilateral is the angle formed by the adjacent side of a quadrilateral by lining within the quadrilateral. So the quadrilateral has four interior points. On the given figure, we have for the interior angle, so angle G, angle D, angle E and angle F are the interior angle of the quadrilateral. Good. And the last point is the quadrilateral DEF contain four interior angles depending the number of the side of the polygon having the number of angles. If the polygon having 5 sides, have 5 interior angle. 3-sided polygon or triangle have 3 interior angle. Good. Are you following me? Well, types of quadrilateral. Types of quadrilateral classified on as follows as below. So the first one is trapezium, parallelogram, rectangles, rhombus, a square. These all are an examples or a part of a quadrilateral. Let's see one by one before we are going to the different types of quadrilateral. Let's have see one focus point. One common property of all quadrilateral, that the sum of all their interior angles are equal to 360 degree. All the quadrilateral having either what? Trapezium, parallelogram, rectangle, rhombus, square, all are the classification of quadrilateral have what? The sum of all the 4 interior angles is 360 degree. Let's see all the given quadrilateral one by one. Let's start from the trapezium. What does it mean, trapezium? You have learned it in grade 6 mathematics lesson, geometric figure and measurement. Trapezium is a special type of quadrilateral in which exactly one pair of opposite sides are parallel. Don't forget, from the other part of the quadrilateral, trapezium has what? Only one pair of opposite sides are parallel. On the given trapezium, this is the geometrical figure of a trapezium having a base and a leg, interior angle, and a height of the quadrilateral or trapezium. Good. What does it mean, an isosceles trapezium? An isosceles trapezium is a trapezium in which a non-parallel side are congruent. A non-parallel side means this one, this is non-parallel side, this and also this non-parallel. This the above one is the base are parallel. So these two non-parallel sides are equivalent or equal. They are said to be an isosceles trapezium. So the non-parallel side or the legs of the trapezium are congruent. AD and BC are, the measurement of the length is congruent, said to be isosceles trapezium. Next, on the given figure a trapezium, which one is the base of the trapezium, the legs and the height. The parallel side are called the base of the trapezium. We have what on the trapezium? The upper and the lower base. So always the upper and the lower base, always they are parallel. The non-parallel side of the trapezium is here to be a legs of the trapezium. So the legs of the trapezium is AD and CD are legs. The distance between the upper base and the lower base of the given trapezium is the height or altitude of the trapezium. Good, student. Let you see one example. Identify from the given figure the parallel side, the non-parallel side, and determine the altitude of the trapezium and also determine the either it is isosceles or not from the figure. We have the figure as shown. So the parallel lines of the trapezium is on the given figure. The parallel side is the base, the upper and the lower base. AB and DC are a parallel side of a trapezium. Non-parallel sides are a legs of the trapezium. AD and BC are a non-parallel side of a trapezium. AE means that the distance between the upper and the lower base of the trapezium known as to be altitude of the trapezium or height. Next is it the given trapezium ABCD is an isosceles trapezium? Yes, definitely. Because their legs, what you call CB and AD indicate that they are congruent. So they are, it is an isosceles trapezium. Good student. What does it mean parallelogram? Parallelogram is a quadrilateral which both pair of opposite sides are parallel. On the given figure, parallelogram, the given figure, this is both opposite side. On the definition, both pair, this one and this one, this one and this one are, both pair are parallel. Let's use the property of the parallelogram. We have around 5 properties of the parallelogram. Let's see one by one. The first one property is the opposite side of the parallelogram are congruent. The opposite side, MN and PO, opposite side, MP and OM, parallel, opposite side. This line indicates the parallelism, and these are the congruency. So the two opposite pair are parallel. Next, the opposite side parallelogram are parallel. The above one is congruent. In the figure one, this one is congruent to this one. POMN is congruent. ONMP congruent to ON. Then the opposite angle of a parallelogram are congruent. Opposite angle. Angle P and angle N are congruent. The measure angle M and the measure angle O are equivalent. So, measure angle P equivalent to measure angle N. Measure angle M equivalent to, thus equivalent to measure angle O. Good. Next property, the consecutive angle of the parallelograms makes supplementary. That means the sum of the two angles are 180 degree. So, measure angle P added with measure angle M, it makes 180 degree. Measure angle N with measure angle M added with 180 degree. So, the consecutive angle of a parallelogram are supplementary. The diagonal of the parallelograms bisect each other. The diagonal of a parallelogram bisect each other. That you see on the figure of parallelogram PONM. This is a diagonal of parallelogram, and also this is a diagonal of parallelogram. When line segment diagonal PN bisect the diagonal MAO, bisect each equivalent. They are equal. Again, this and this are equivalent. And also PR equivalent to NR, MR equivalent to OR. What does it mean bisect? Bisect means divided exactly into two equal parts. Good student. Let's see one example. If 65 degree is one angle of the parallelogram, find the degree measure of the remaining angle. On the quadrilateral, especially a parallelogram, one angle of degree measure 65 degree. What is the degree measure of the other's angle? Let's draw parallelogram A, B, C, D. The degree measure of B is 65. Let's find the other's remaining angle. In the given figure, ABCD is parallelogram given, and one angle is given 65 degree. So the measure of B, the measure of B and the measure of D are equal. Because 65, because the opposite angles of a parallelogram are congruent or equal. So the two angles are this one 60 and also this one is 65 degree. Next, the measure of angle A and B. This is the measure of angle A and B because they are consecutive angle. So the two angles are 180 degree. because the consecutive angles are supplementary. So the sum is 180 degree. So the measure of angle A is 180 degree minus measure angle B. So equivalent to, we get 115 degree. So this one is measure angle A is 115 degree. So measure angle A and measure angle C are opposite angle. So by the definition of a parallelogram, the opposite angles of the parallelogram are congruent. This measure angle C also 115 degree. Give the student. Next, let's see rectangle. Another name of rectangle is equiangular parallelogram. If a parallelogram having equal angle, we say also what? Rectangle. Rectangle is a parallelogram whose angles are right angle. All angles are right angle. We have the property of a rectangle. A property of a rectangle. The rectangle has all the property of a parallelogram. We know previously all the 5 property of a parallelogram that contained in the property of rectangle. Next property, the rectangle contain 4 right angles. 4 right angle, 90 degree. 4 right angles. Then on the diagonal of rectangle are equal. Not to construct a rectangle, it is sufficient to know the lengths of the 2 adjacent sides. The 2 adjacent sides. If a parallelogram has congruent diagonal, then it is necessarily a rectangle. Example, in a rectangle ABCD, length of diagonal AC is 20x plus 12, and the length of the diagonal BD is given by 14x plus 24 centimeter. Find the lengths of measure AC and BD. Give the student. Here we see the solution. ABCD is given a rectangle. AC is 20x plus 12 centimeter and BD is 14x plus 24 centimeter. By the definition of rectangle, we have the BD equivalent or congruent to AC because the diagonal of rectangles are congruent. So the measure angle BD, measure side of the length of a measure of the side of BD are 14x plus 24 centimeter equal to 20x plus 12. So rearrange and collect the like term. So 14x minus 20x, we get 12 minus 24. So we get minus 6x is equal to minus 12, both sides divided by negative 2. So we get finally x is equal to 2. Then AC is 20x plus 12. Substitute the given value of x is 2. 20 times 2 plus 2, we get 52 centimeters, the length of the line segment, the diagonal of AC of the rectangle. And also BD is 14x plus 24. 14 times 2 plus 24, we get again 52 centimeters. Finally, therefore, AC and BD are equal 52 centimeters. This indicates the diagonal of the rectangles are congruent. Good. Student, you remember the property of rhombus? I hope you remember. Rhombus, another name of rhombus is lozenge or equilateral parallelogram. Rhombus is a parallelogram whose sides are equal. All the sides are equal. So, all the sides equal. All the 4 sides are equal. The properties of rhombus. Rhombus has the property of a parallelogram similar to the rectangle, and the diagonal of rhombus perpendicular each other. The diagonal of rectangles perpendicular to each other. And also, on the given one, a rhombus has all the sides are equal or congruent sides. The diagonal of rhombus bisect each other. Bisect means previously divided in exactly into two equal parts. So the diagonals of rhombus bisect each other. Finally, the diagonal of rhombus bisect its angle. The given angle of the rhombus divided into two equal parts. Good. To construct the rhombus is sufficient to know the length of the side and one angle's measures. If ABCD is a rhombus with the side length is 5 centimeter and AC diagonal is 6 centimeter, find the length of BD. So the given rhombus ABCD, the diagonal is 6 centimeter, one side of the rhombus is 5 centimeter. That means all the side of the rhombus is congruent. So this is 5 centimeter, again this 5 centimeter. And also the property of rhombus, the diagonals bisect each other, so divided into equal parts. Here we have the solution of the given rhombus. Since ABCD is a rhombus, from the property of the diagonal of the rhombus is perpendicular bisector of each others. So take either of the triangle formed, which are right angle triangle on this one. So we have get right angle triangle on this one. This is right angle triangle. It makes perpendicularity 90 degree. We have the center point E. Put it. So we get it. This one, this figure, a right angle triangle. So the right angle triangle 90 degree. We have what? The base and also the hypotenuse, the length, the largest side 5 centimeter. So the side on the above figure, this one is E. AC is 60 centimeter. The distance between from A up to E and from E up to C is half of the length of AC. So AE and CE are equivalent. So on the rhombus CA, AC and half of AC is 1/2 times 6 centimeters, 3 centimeters. So AC, this is CE or AC. So this one is 3 centimeters. We get it. Then the diagonal bisect each others by Pythagoras Theorem. You know, the mathematician Pythagoras. So the Pythagoras Theorem says that the sum of, on the given right angle triangle, the sum of the two sides, the square of the two sides equivalent to the square of the largest side of the right angle triangle. So AC square plus BE square is equal to BC square or 5 centimeter square. Substitute the given formula, 3 centimeter square plus BE square 5 centimeter square. We get this one is 9 centimeter square plus BE square is equal to 25 centimeter square. So rearrange the given BE square means 25 centimeter square minus 9 centimeter square. We get BE square is equal to 16 centimeter. Then finally BE square means BE times BE, 16 centimeter means 4 centimeter times 4 centimeter. So BE means 4 centimeter. So on the figure, BD means DE plus BE, because the diagonal bisect each others. DE plus BE, they are congruent. 4 centimeter plus 4 centimeter. BD is 8 centimeter. Good. On the last, the classification of the quadrilateral square. A square is a rectangle whose the sides are equal. This is the geometrical figure of a square. All the sides are equal. Then the angles are 90 degree. The property. So on the given property of the square, all the sides are equal. AB equal to BC, again equal to the length CD, again the line segment DA. They are equivalent. And also all angle of the square are right angle. That means they are 90 degree. 90 degree. All angles are 90 degree. The opposite side of the square are parallel. This side DC and AB are parallel, and also this one and CB are parallel. The diagonal of a square are perpendicular and congruent to each other. The diagonal of a square, this is diagonal BD and diagonal AC. They are, when they intersect or cross each other, it makes 90 degree. And also, they are congruent. The length of BD is equal to the length of BD equal to line segment AC. They are congruent and also bisect each other. The diagonal of the square bisect at an angle of the vertex. Here we see on the figure the diagonals. The diagonals, when the diagonals bisect each other, the diagonal bisects at the vertex one, divided into, this is 90 degree. So this is 45 degree, and also this one is 45, because bisect at an angle of the vertex. So the measure of ADE, these angles, and also CDB, these angles 45 degree. Good. Let's see, we see the relation between and the classification of the quadrilateral. So on the given quadrilateral, we have two mainly group, the parallelogram and the trapezium. When you come to the trapezium, is trapezium having the upper and the lower base. If the trapezium, the non-parallel sides are legs, if the non-parallel side or the legs of the trapezium are congruent, what you call as an isosceles trapezium. If the parallelogram having a classification rhombus may what a rhombus and rectangle, rhombus may what rectangle and a square. But when you say the given quadrilateral classification, the classification from a square is, every square is rectangle, every square is rhombus, every rhombus is a parallelogram from the bottom to the top is always is true. And also from the above one, from the top to the bottom is false. So when take an example, every parallelogram is a square, it is false. So you understand from the given chart. Good. Example, which one of the following is a figures have always perpendicular diagonals? Perpendicular diagonal. So rectangles, B, trapezium, rhombus, parallelogram. So the answer should be a perpendicular diagonal is rhombus, because that is the diagonal of rhombus perpendicular to each other. Let's add one more examples. In the figure below, ABCD is a square. AB is 4 centimeter. The length of BC, CD, and AD measure angle ABD and measure angle ADB, and also the measure angle AEB, this one. So from the figure, the length of the given one, this one, and on the required of A, the measure of the line segment of BC, CD, DA is 4 centimeter, because the figure on the figure is a square. A square is a congruent side. And also the question number B, the measure of ABD is half of the measure of the angle B. So the measure of the angle, the interior angle of the square are 90 degree. The half of 90 degree is 45, and also the half of the measure angle D is 45 degree. because the diagonal of the squares bisect at an angle of the vertex. The last one, the measure angle EAEB is 90 degrees because the diagonal of the square bisect perpendicular to each other at the center one. Next, polygon. Students, do you remember the last class, the last grade? What does it mean, polygon? Polygon is a simple closed plane figure formed by 3 or more line segments joined end to end. Triangle, quadrilateral, pentagon, hexagon, all are an example of polygon. The name tell us how many sides they has. The line segment forming a polygon called the side of the polygon. The common endpoint of any two sides are a vertex of the polygon. Let's differentiate the simple and the complex polygon. A simple polygon is a polygon does not intersect the line itself and does not have a hole. So this is an example of simple polygon. All are no intersection point on the given polygon. All are no intersection point. So this is a practical example of a simple polygon. When you come to a complex polygon, does intersect itself, does the whole, they intersect itself when cross each other, intersect at the point, and also let you take a pentagram, intersect at a point, and also this one, and a hole. So this is an example of a complex polygon. Let you see the difference between concave and convex polygon. The convex and the concave polygon classified into various types based on the measure of the interior angles. So a convex polygon is the measure of the interior angle. All interior angle is less than 180 degrees. For example, we have seen the different types of polygon. So in this type of polygon, no portion of diagonal in the exterior part of the polygon. Let you take an example. This is an example of a convex. All the interior angles of the given polygons less than 180 degrees. Or this is a triangle. Each angles are less than 100. Again, this one one less than each interior angle less than 180 degrees. Again, what does this mean? Concave polygon. Concave polygon is a polygon at least one interior angles greater than 180 degrees. At least one. More than 180 degrees. I said to be what? A concave polygon. The vertices of a concave polygon are inward as well as outward. So let you see on the practical example. This one is a concave. The interior angle greater than 180 degrees. The polygon, the vertex of the vertex is inward. This is outward. Again, this was inward is greater than 180 degrees. This one is greater than 180 degrees. The diagonal of a convex polygon. The diagonal of a convex polygon is a line segment whose endpoints are an non-consecutive vertex of the polygon. Let you see the given polygon of hexagon from point A, from the above hexagonal polygon, a vertex A, from the vertex A, we have what? The diagonal of AC, AD, and AE are also the diagonal of a polygon. And also from the quadrilateral ABCD, from the vertex A, we can draw the diagonal AC from BAD, what you call the diagonal. Another main point on this one is, we have the diagonal of a polygon depending the number of sides of a polygon. the polygon classification on depending the interior angles and the sides measures and the intersection of the point. So this is all about our today's lesson. Goodbye, student.